the one that we need to talk about now are stereoisomers. So stereoisomers mean that they're actually connected exactly the same. Their orientation in space is differently. This is where the molecule kits would have really, really helped. However, I don't have them, we'll have to make do. There's two ways that we can talk about stereoisomers. We can talk about them with double bonded compounds, so alkenes, and with cyclical compounds. So let's focus on this one because this is actually the next one on your sheet. If I said to you, can you name this for me? You'd be like, oh, okay, 1, 2, 3, 4, it's a butene. Where does it start? The double bond starts at the second and goes to the third. So 2-butene or butene, it's fine, and it has this chemical formula. The thing is when you actually put these together with the molecule kit, you actually get a zigzag compound, right? And that's because the actual angles are going to be 104.5 between these two carbons. And here they're going to be 120. So when you physically put them together, you can see that while we write them like this, just because it stays on the line neater, in actuality, they look like this when you put them together. There's two ways you could actually put it together. You can put it together so that it looks like this kind of, I don't know, whatever, and it looks like this. So same formula, hence it's an isomer, same connectivity. I've got a carbon to a carbon, carbon to a carbon, carbon double bonded to a carbon, carbon double bonded to a carbon, and lastly, carbon-carbon. So same formula, same connectivity, but their spatial orientation is completely different. These have different physical properties, and it's really important to be able to distinguish between the two of them. So they came up with this cis-trans method of naming. The way that I remember it is, and this is stupid, but it works, is I would say cis the same side. It's like a lot of S's together. You know, trans doesn't sound as much as cis the same side. So cis means that these groups coming off the double bond are going towards the same side of the molecule. And in that way, I'm talking about if you look at your double bond like that, they're on the bottom side of the double bond. Whereas trans, they're across from each other. One is down and one is up. Okay, so I'm not sure how you're gonna remember it, but that's how I remember it. Cis, the same side. So how do you put it in the name? Well, you would still call it a 2-butene or butene, and all you do, and technically should be using italicized lettering, but just you write cis-2-butene, and that would tell me that these two are coming down, and trans would tell me that they're coming up. This is the way that we've traditionally done it. This is the way that you'll probably still see it. There is a new, improved way, which is E and Z. So for reasons that I don't really want to get into right now, maybe I will, we'll see, they came up with an even more accurate way of naming cis and trans compounds, or of naming these stereoisomers. Comes from the German words. So the German, we're recollecting our best German. The word together is zusammen, which starts with a Z in German, and zusammen means together. So Z says they are together. And this is entgegen, which is alone or opposite? Maybe opposite. Entgegen? I'd have to look that up. But anyway, Z also works nicely, Z's the same side. So, I mean, whether you're saying cis the same side or Z's the same side, that's what that means. And again, you're just putting the letter out in front of the name. You still have to tell me it's a 2-butene, because if it's a 1-butene, this isn't actually an issue, which is a good point. I didn't talk about this last time. See, good that we're doing it twice. If you had a 1-butene, I would draw it like this. So carbon, carbon, 1, 2, 3, 4. If I were drawing with the stick figure, 1, 2, 3, 4, I have a hydrogen and a hydrogen and a hydrogen. So if you take a look at that, let's just turn our paper like this. So now all of a sudden I have this thing. Because there isn't a bigger group coming off of here, it doesn't matter whether this H goes up and this H goes down, there is no actual cis and trans for this one, because you would have needed something here to be apart or on the same side. Because these are exactly the same, you don't need to name it cis and trans. That's a good point, I didn't talk about that. So cis and trans only works is if you've got a double bond in the middle of a compound with a larger component coming off, a smaller, because remember, here is my little H, and here is my little H, here's my H, and here's my H. So you're never gonna have a 1-butene having cis or trans, it doesn't happen. You can do cis and trans with methyl groups coming off. You know, if I had an ethyl group coming off of here, this would still be considered cis, or Z, because the groups are coming together, or they're together off the double bond, right? If I had this would still be trans because this group is pointing down, and this group, even though it's not the same group, but it's a large group, is pointing up. So that would be trans, and this would be cis. So it doesn't always just have to be a butene. It could be a 2-pentene, and you would still have cis and trans. Furthermore, in case you have an example like this, so I have carbon double bonded to a carbon to another carbon. So 1, 2, 3, 4. Off the second carbon, I have a fluorine, and off the third carbon, I have a chlorine. You're going to do the exact same thing, except here you're like, oh, well, I've got the carbon down and the carbon up. This is why the EZ method came of naming, because if you'd gone to the previous example, you'd say, well, the carbons are across from each other, so it's trans. However, the EZ method says, okay, if you have this messy compound that's got carbons and fluorines and chlorines and bromines, what you're going to do is you're going to split the molecule in half, and you're going to prioritize these substituent groups. So on this half, you have to figure out which has highest priority. And highest priority is the one that has the higher molar mass. So if you take out your periodic table, fluorine has a higher molar mass than carbon, 19, 12. This gets the first priority, this gets the second priority. Over here, chlorine has a higher molar mass than carbon, first priority and second priority. Now, the EZ method says you look at where the first priority groups are in relation to each other. So here they are entgegen, they're across from each other. So that would be E, and then you would name it accordingly. You would say, okay, it is, how would we name this one? I have a but-2-ene. What do I have on my but-2-ene? I've got a 2-fluoro and a 3-chloro. C comes before F, so that would be a 3-chloro, I've got to print tiny here, 2-fluorobutane, but then you have to tell me whether the 3-chloro and 2-fluoro are E or Z, because they're priority and they're across from each other. You would just stick an E out in front. So that would be E, 3-chloro, 2-fluoro, but-2-ene. Ugh, okay, clear as mud. Let's see what's on the back of this. Let's see. Oh, there you go. More examples of the same. Here's another example. I've got 2 fluoros on here. Again, I'm going to write, it really helps if when you see a double bond in the middle of a compound, you actually write the double bond and then try to figure out what's coming off of it. In this particular case, right, I have a fluoro up and the fluoro up. Remember, fluorine has a higher priority because it has a larger molar mass than carbon. So priority up, Z's the same side. Okay, so that one would be named Z, 2,3-difluoro-2-butane. Here, they're opposite, so that would be E. This equivalent would be cis, that would be trans. Technically, the better way to name is E and Z because it allows you, if I stuck, I don't know, the example would be if I change this to a bromine. You see where the cis and trans runs into problems is, say I had bromine and fluorine and another carbon. There's no way to name this using cis and trans because you'd be like, well, these are trans, but these are cis and whatever. That way, this gets priority because it's bigger. That second, this gets priority, that second. And you would say, according to those things, the 2 number 1 priorities are on the same side. So that would be Z. We run into problems with cis and trans here. I don't think you're going to run into problems in 4U chemistry with E and Z, but that's how you do it. So if you see it next year, you'll remember that you did look at this during coronavirus. Okay, that's it. I'm going to move on to another cup of coffee. We're going to look at cyclical compounds. This will be a pretty quick lesson. I think I can do it in about 5 minutes. So taking a look at a cyclical compound, let's look with the fictitious cyclobutane. And the reason I'm going to use cyclobutane is because here is cyclobutane. Here's my 4-sided figure. There we go. So I got a 4-sided figure. So not that it exists because there's ring string, but if it did, I had a 4-sided figure, and say I wanted to stick a chlorine here and a chlorine here. So first of all, what would I name that? I would name that 1,2 dichlorocyclobutane. cyclobutane. But here's the thing. On paper, that looks fine. In real life, I could potentially have, oh, just a sec. Katerina, can you come here for a sec? I need your help. You want to stick your head under and say hello?
Hi.
Okay, so my daughter is holding up the dichlorocyclobutane. If I want, it's a Crayola box, but it could also be cyclobutane. If I have two chlorines, you can see pretty easily that I can either have them both up or I can have one up and one down. And that's simply they are connected exactly the same. It's just their spatial orientation is different. This would be cis, same side. This would be trans, opposite side. So now we're looking across the plane because all cyclostructures are planar. Across the plane, are they both up? Is one up, one down? Technically, this would be cis. Both pointing down would also be cis. Thank you, Katerina. So how would you draw it? To show that the Crayola box is in the plane, meaning flat, you can simply show it like this, one up, one down. That would imply going up, coming down. So that would be up, down. This would be the trans 1,2-dichlorocyclobutane. This would be the cis, pointing up, or I guess technically pointing down. That might even be less than 5 minutes. So that's stereoisomers with cyclical compounds.